Let's see the meaning of acute angle bisector between two lines. Let's say this is line L1, guys, and this is line L2. So as you can see here, this is the acute angle between them, right? And this one, like this is obtuse angle. So if I draw a line like this, which is what I call the bisector of this acute angle, let's say this is some bisector B1. So B1 is what I call acute angle bisector of angle between the two lines L1 and L2. Obviously the other line would be, this would be, if I draw, this would be obtuse angle bisector, and this is acute, this is what we call acute angle bisector. So if the equation of two lines are given, so guys, this is acute angle bisector, this one acute angle, this is angle sign bisector, and this is obtuse angle bisector. So the question arises, how to find the acute angle bisector, and if you can find the acute angle bisector, the other bisector obviously would be the obtuse angle. So finding acute angle bisector means finding the other one as well. So what is the condition of finding the acute angle bisector? What we are here interested is to get the shortcut of finding acute angle bisector, because the long way is, we already know that this angle is theta, this angle, whole angle is theta, so theta by 2 is, theta is less than 90, so theta by 2 is less than 45, and then we find the bisector line and then find the angle between the bisector line with L1 or L2, and the modulus of tan theta should be, theta by 2 should be lesser than 1. That is the long traditional way, conventional way of solving it. Here what we are interested in this discussion is to get the acute angle bisector between the two lines using a shortcut. So this is what we are interested is finding this bisector, let's say B1, which is what we call acute angle, because it is bisecting the acute angle between the two lines L1 and L2. Here we are assuming that L1 and L2 are not perpendicular, because if they are perpendicular, both the bisectors would be same, considered same, because they both be bisecting at 45 degrees. So let's see how to find, guys, the shortcut of acute angle bisector between the two lines. Before that, let's try to understand few things. Let's say L1, if I define L1, expression of L1 is nothing but a1x plus b1y plus c1, or equal plus c1 also we can take, equal to c1 also we can take. So L1 xy equals to 0 means a1x plus b1y equals to c1. This is line L1, which is this. Okay. So similarly we can define line L2 x comma y equals to 0 means a2x plus b2y. So here we can write L1 xy, we can define L1 expression as minus c1 equals to 0, minus c2 equals to 0. So this expression is basically L2 xy. Okay, that we will keep in mind. Okay guys, so here first thing I am interested is, let's make c1 and c2 positive, it can be derived by making both the both c1 c2 negative also. But if you make a1x plus b1y equals to c1, and my question now is to convert it into normal form. Okay, so normal form, L1 if we are converting, we will divide it by what? If you remember, we divide it by under root a1 square plus b1 square plus b1 under root a1 square plus b1 square y equals to c1, same thing, under root a1 square plus b1 square. So this is what? This is equivalent to x cos alpha plus y sin alpha equals to p1, right? Similarly, the other line L2, we can convert it to normal form as a2x by under root a2 square plus b2 square plus b2 by under root b2 square plus b2 square y is equal to c2 this time, upon under root a2 square plus b2 square, which is equivalently x cos beta plus y sin beta equals to p2. That's why we made c1 and c2 positive, because p1, the length of perpendicular from origin on the line, is positive. Okay guys, now here if I ask you what is cos alpha minus beta, so as you can see here, this cos alpha is this thing, sin alpha is this thing means sin alpha is b1 upon under root a1 square plus b1 square. Similarly, cos beta is a2 upon this under root, sin beta is b2 upon this. So if I am interested, if I ask you what is cos alpha minus beta in terms of the coefficient a1, b1, a2, b2 and so on, what you will say guys? So guys, it is, if I ask you cos alpha minus beta using compound angle results from trigonometry, it is cos alpha cos beta plus sin alpha sin beta. So cos alpha cos beta is a1 upon under root a2 upon under root b1 upon under root b2 by under root. So cos alpha minus beta basically turns out to be a1 a2 plus b1 b2 upon under root. So these two under root are what? Here it is, let me write it, this, and here it is a2 square plus b2 square guys. So this is cos alpha minus beta. This is result number 1. This we will use guys later. Okay. Now another thing, what if the lines given, what is the line? Bisector line containing origin. When I made these two lines, when it is given that C1 is positive, so minus C1 equals to, this is L1 and this is L2 guys. So we know that L1 and L2 origin values, if we find the product, which is minus C1 into minus C2, since C1 C2 is positive, negative negative becomes positive, so bisector line containing origin would be given by L1 by under root, L1 means this whole thing, under root means under root a1 square plus b1 square is equal to plus L2 by under root here a2 square plus b2 square, and L2 is, what we mean by L2 is this expression a2x plus b2y minus c2. So the bisector line containing origin is given by this. Let's say this is second conclusion. Okay, now let's move on to finding acute angle bisector. Now there are so many scenarios. Here we are considering C1 C2 as positive. If any one of them becomes 0, then also the following derivation which I am going to tell you will be valid. Okay, so now first and second result we will use in this. Now let's see the different scenarios of when two intersecting lines on a coordinate plane, how it looks like, guys. So guys, it's like this. This is, let me draw the axis like this, and another axis is like this. This is y axis, this is x axis, guys. X axis, y axis, positive y. Now if I draw two lines like this, one is like this, guys, and another it goes like this, guys. So this is L1, this is L1, guys, this is L2, guys. Now as you can see, this is the origin. Now if I draw another line, which is what I call the acute angle bisector. See, this angle is acute, this is acute, so acute angle bisector would be like this, guys, somewhere like this, yes, somewhat like this. So this is acute angle bisector, and as you can see, this is containing origin in this case. So if I drop perpendiculars now from this origin to these two lines, guys, let me draw perpendicular on line L1, it will be like this, guys. Okay, and then let me draw a perpendicular on this, so it would be somewhat like this, guys. So guys, as you can see here, this is alpha and this is P1, guys. Okay, and this is this whole thing is beta angle, guys, and this length is P2, guys. Correspond this is L1 na. So guys, this I rename as L2 and this is L1. Now it is okay. So as you can see here, this is beta is the angle made by the perpendicular drawn from origin on L2, and this is L1. Alpha is the inclination of the perpendicular. So inclination, if I am using the word, it is inclination of the perpendicular, it is not the inclination of the line L1. Okay, so guys, as you can see here, the difference between the angle alpha and beta, as you can see, is it acute or obtuse? I will take modulus here because there may be L1 L2 can be interchanged also, the way I did. So as you can see here, alpha minus beta is obviously it is greater than pi by 2, because this angle, as you can see here, this is obtuse. Okay, so alpha minus beta in this scenario, as you can see, the two lines, the acute angle bisector is containing origin also, and the angle made by the perpendiculars, their difference is greater than pi by 2, it is obtuse rather. Now this we can generalize. Now if you take any other scenario, like if it is something like this, and if you draw the lines two lines L1 L2, if you draw like this, this is the bisector line. Okay guys, so again if you draw various perpendiculars from the center origin, as you can see here also in this scenario, the bisector, acute angle bisector, let's say this is B1, okay, this is XY, this is containing origin in this case, and if you draw perpendiculars on the two lines, one on this, another like this, okay, so you will see the angle between them is again obtuse, which is this. So similarly, the similar scenario in this is the first quadrant I have drawn, this is the second quadrant, third and fourth also we will notice that alpha minus beta mod is greater than pi by 2 will prevail, it will be there. Okay, so in short, acute angle bisector, okay, if we want to calculate, we have to calculate what? We have to calculate the bisector B1 which is containing origin, guys, which is containing origin also. So as you can see, acute angle bisector is containing origin and alpha minus beta mod is greater than pi by 2. So what it means is, since alpha minus beta mod, let's see this on next page, guys. So since alpha minus beta is greater than pi by 2, cos alpha minus beta is what, guys? Positive or negative? So yes, it is negative, and from conclusion 1 that we have drawn, cos alpha minus beta was a1 a2 plus b1 b2 upon under root a1 square plus b1 square into under root a2 square plus b2 square is negative. So which gives us what? a1 a2 plus b1 b2 as negative. So we can also say that if you calculate a1 a2 plus b1 b2 as negative, because this under root is positive only, so it has no bearing on the entire sign of this expression. a1 a2 plus b1 b2 is lesser than 0 if it is negative, then the acute angle bisector will be the bisector containing the origin, and the bisector containing the origin is L1 by under root is equal to plus L2 by under root, which is the acute angle bisector also and the bisector containing origin also. So this is acute angle bisector, guys. In a similar fashion, if a1 a2 plus b1 b2, it can be proved that if it is positive, acute angle bisector is given by L1 by under root equals to minus L2 by under root. Okay, now if you ask then how we will calculate obtuse angle? So obviously if this is acute angle for plus sign, when we are getting a1 a2 plus b1 b2 less than 0, obviously for minus sign we will get obtuse angle bisector. So if there a1 a2 plus b1 b2, this is the shortcut, guys. If it comes out to be negative, L1 by under root plus L2 by under root will give you acute angle. So if you replace this plus by minus sign, it will give obtuse angle. And similar thing happens in the second case when a1 a2 plus b1 b2 is positive, minus will give acute, so plus will give obtuse angle bisector, guys. Okay, when c1 c2 both are equal to 0, the bisectors are calculated geometrically also. Okay, so this is the most generalized version. Okay, when we calculate a1 a2 plus b1 b2 subject to c1 c2, we have seen in the very beginning either both positive or both are of the same sign, that is both are negative or both are positive, guys. Okay, so let's see this with an example, guys. Three x minus 4y minus 2 equals to 0. Find acute angle bisector, and 5x plus 12y minus 11 equals to 0. Here c1 and c2 I have chosen to be of the same sign directly. So now a1 a2 plus b1 b2, if you calculate, it is 3 into 5 plus minus 4 into 12, so 15 minus 48 is negative. So acute angle bisector, if the question is this, if the question is acute angle bisector is what, so L1, which is this, by under root which is this, we will take which sign, guys? Plus or minus? Upon under root 5 square plus 12 square. So yes, if this is negative, we will take plus sign, guys. So 3x minus 4y minus 2 by 5 under root of 3 square plus 4 square is 5. 5x plus 12y minus 11. 5 square plus 2 is 12 square. Using Pythagorean triplet, it is 13. I will cross multiply this and we will solve, and we will get the answer, which would be the acute angle bisector, guys. Okay. So for obtuse angle bisector, obviously this plus sign would be replaced by minus. So okay guys, thank you.